August 22, 1916. Somewhere along the Somme front, in a shallow pit scraped from the chalky French earth, a team of British soldiers are doing something that should, by every mechanical law of the age, be impossible. For the past 2 days and 11 hours, 107 hours of near-continuous operation, a single water-cooled machine gun has been firing into the grey morning air. The barrel casing steams, the ammunition belts snake across the ground in long, gleaming lines. The men rotate in shifts of 2, feeding ammunition, monitoring water temperature, wiping away cordite residue with rags that are now entirely black. The gun itself does not stop. It has not stopped. And remarkably, astonishingly, it will not stop. Not because the men refuse to let it, not because the tactical situation demands it, but because the machine is built, in ways that its German counterparts simply are not, to keep going until the men themselves can no longer continue. That gun is the Vickers .303 Mark I, and the achievement recorded that August, by the 100th Company of the Machine Gun Corps, stands as one of the most extraordinary demonstrations of mechanical reliability in the entire history of warfare. 10 Vickers guns fired just under 1 million rounds in that single 12-hour period. Not one of them stopped, not one of them jammed, not one of them failed. When the barrels finally fell silent, it was because the ammunition ran out, not because the guns gave way. In a war defined by catastrophic mechanical failure, by rifles clogged with mud, by artillery pieces that cracked under their own stress, by lorries that sank into the Flemish clay and never came out, the Vickers machine gun stood apart. It was, and it remains, one of the finest pieces of military engineering ever produced by British hands. This is its story. It was, and it remains, one of the finest pieces of military engineering ever produced by British hands. To understand why the Vickers mattered so profoundly, you have to go back to the decade before the First World War and understand the peculiar relationship that the British Army had with machine guns, which is to say, a relationship built almost entirely on suspicion and institutional inertia. As late as 1909, the British Army officially allocated just 2 machine guns per battalion. 2, a force of several hundred men expected to hold and take ground against modern European armies, was given the same number of machine guns that a reasonably well-funded colonial police unit might possess. The thinking, such as it was, ran along predictable lines. Machine guns were heavy, complicated, difficult to operate, prone to jamming, and above all, they were expensive. They required specialists to operate and maintain them. They were, in the minds of many senior officers, a distraction from the proper business of soldiering, which involved men with rifles advancing in disciplined lines. That thinking would be catastrophically dismantled in August 1914. The German army, which had no such institutional resistance to the machine gun, deployed their Maxim-derived MG-08 in numbers and with a tactical sophistication that the British had not anticipated. At Mons, at Le Cateau, at the Marne, German machine gun crews inflicted casualties on advancing British infantry at a rate that bordered on the industrial. A single well-sighted gun with a competent crew could stop a battalion in its tracks. And the Germans, having thought about this problem considerably more carefully than their opponents, had many, many well-sighted guns. The British Army, which entered the war with roughly 1,500 machine guns across the entire expeditionary force, found itself in a situation that combined tactical surprise with mechanical inadequacy. The guns they did have, the original Maxim design that had underpinned British machine gun doctrine since the 1880s, was serviceable but aging, and their operational doctrine for deploying them was, to be generous, underdeveloped. What was needed was not merely more guns. What was needed was a better gun, organized into dedicated units with proper training and tactical doctrine, and deployed in numbers that could match and then exceed the German capacity for sustained fire. The Vickers answered the first requirement. The creation of the Machine Gun Corps in October 1915 addressed the second. Together, they transformed the character of British fire support and, ultimately, of the entire Western Front. The Vickers had its origins in the workshop of Hiram Maxim himself, the American-born inventor who had created the first truly practical, fully automatic machine gun in 1884. Maxim's original design, adopted by the British Army as the .303 Maxim, was a remarkable achievement, but it was heavy, complex to maintain, and temperamental in field conditions. It weighed nearly 28 kilograms without its tripod, and with the tripod and water in the cooling jacket, a complete Vickers system in the field could weigh close to 50 kilograms. That weight was not arbitrary. Every component served a purpose, but the sheer mass of the system made it difficult to move quickly, and in the fluid early months of the war, that mattered. What Vickers, Sons and Maxim, the Barrow in Furness engineering firm that had acquired the rights to the Maxim design in 1896, achieved was a thorough, systematic re-engineering of the original concept. Their chief designer, working through the late 1890s and into the first decade of the 20th century, inverted the lock mechanism of the original Maxim, reducing the overall weight by approximately 18% and improving the mechanical reliability of the action in the process. The resulting weapon, formally adopted by the British Army as the Vickers Machine Gun, Mark I in November 1912, weighed roughly 18 kilograms for the gun itself. Still heavy, but meaningfully lighter than the weapon it replaced and operationally far superior. The genius of the Vickers lay in its operating principle. It was a recoil-operated weapon, meaning it used the energy generated by each fired cartridge, specifically the rearward force transmitted through the cartridge case as the propellant gas expanded, to operate the mechanism. As the barrel and bolt recoiled together, a toggle joint below the receiver broke downward, unlocking the breech and allowing the bolt to travel rearward against the pressure of a coil spring. This action extracted and ejected the spent cartridge case, compressed the return spring, and allowed the feed mechanism to advance the next round from the 250-round canvas belt into the feedway. On the return stroke, the bolt stripped the fresh cartridge from the belt, chambered it, and the toggle joint snapped back to its locked position, ready to fire again. The whole cycle took approximately 1/100th of a second. At its standard rate of fire, between 450 and 600 rounds per minute, the Vickers could empty an entire 250-round belt in roughly 30 seconds. The water cooling system was the other defining feature of the design. Around the barrel was a jacket containing approximately 3.5 liters of water. As the barrel heated during sustained fire, this water absorbed the thermal energy and kept the barrel temperature within operational limits. In extended engagements, the water would begin to boil. A flexible hose from the jacket's steam outlet could be routed into a condenser can, where the steam reconverted to water and drained back through a second hose, meaning that a competent crew, maintaining the condensation system properly, could fire almost indefinitely without needing to change barrels or risk the catastrophic overheating that crippled air-cooled weapons under similar conditions. It was not, strictly speaking, an unlimited system. The water level dropped over time. Condensation was never perfectly efficient, but in practice, the system extended operational endurance far beyond anything an air-cooled design could achieve. A German MG-08 crew, under the same conditions of sustained fire, would typically need to change barrels every 250 to 400 rounds. A Vickers crew, managing their condensation system correctly, might fire several thousand rounds before intervention was required. Production of the Vickers was centred primarily at the Vickers Works at Crayford in Kent and at Erith, also in Kent. As the scale of the war became apparent and demand escalated sharply from 1915 onwards, additional production was established at Birmingham, and a number of subcontractors contributed component manufacture. Exact production figures remain partially classified even today, but estimates suggest that somewhere between 71,000 and 78,000 Vickers guns were produced for British and Commonwealth forces over the course of the First World War, a figure that understates the true industrial achievement, because each gun required the precise manufacture of several hundred individual components to tolerances that were, by the engineering standards of 1915, genuinely extraordinary. The barrel alone was subjected to proof firing and gauging that rejected a significant proportion of production. Quality control at a scale and rigor that most contemporary manufacturing could not match. In operational terms, the Vickers transformed the character of British defensive firepower from 1915 onwards in ways that are still not fully appreciated in popular histories of the war. The gun was assigned to the Machine Gun Corps, formed in October 1915, specifically to manage the increasingly specialized business of machine gun warfare. Rather than parceling out guns, 2 to a battalion, and leaving infantry officers, with no specialist training, to decide how to use them, the Machine Gun Corps concentrated Vickers guns under officers and NCOs who had been trained exclusively in their employment. The tactical doctrine that emerged was sophisticated, systematic, and extraordinarily lethal. The most significant development was the concept of indirect fire. Just as artillery could be aimed at targets invisible to the gunner, a Vickers, set on its tripod with a dial sight and firing to carefully calculated range tables, could engage targets over a ridge, around a bend, or in the darkness, areas where no one could aim directly. The gun's extreme mechanical consistency made this possible. If the Vickers fired with predictable regularity and the ammunition was consistent in its propellant loading, then the fall of shot could be calculated with the same mathematical rigor applied to a howitzer. Machine gun barrages and sustained indirect fire along fixed lines became a significant part of British tactical planning by 1916. During the Battle of the Somme, Vickers guns were used to lay down protective barrages over the heads of advancing British infantry, suppressing German movement in areas beyond the infantry's line of sight. It was a use of machine gun fire that the weapon's original inventors had never envisioned. The psychological impact on German forces was considerable and well documented in prisoner interrogation reports and German unit diaries of the period. German soldiers who had been under Vickers fire consistently described the psychological effect of its sustained mechanical regularity as profoundly different from that of rifle fire. A rifle company might fire in bursts, slow down, speed up, and eventually fall silent as men tired or fell. A Vickers, managed by a trained crew, fired with a metronomic consistency that conveyed with terrible clarity that the weapon on the other side was not tiring, not getting cold, not losing its nerve. It simply continued. For men lying in shell holes or moving through broken ground, the constant traversing of a well-positioned Vickers, its distinctive, measured cadence cutting across the background noise of the bombardment, had an effect on morale that the raw casualty figures alone do not fully capture. The German equivalent, the MG-08, was a weapon of considerable quality in its own right. It shared the Maxim recoil operating principle, was water-cooled in the same manner, and in terms of raw firepower was broadly comparable to the Vickers. The MG-08 weighed approximately 26 kilograms for the gun alone, considerably heavier than the Vickers, and its distinctive sledge mount, the Schlitten, added a further 32 kilograms, giving a total system weight of close to 60 kilograms. This made the MG-08 considerably harder to maneuver in the field and significantly slower to bring into action from a static position. The Germans compensated for this limitation with the MG-08/15, a lightened variant introduced in 1915 with a bipod instead of a sledge mount and a reduced water jacket capacity, bringing the weight down to roughly 18 kilograms, almost exactly that of the Vickers. But the MG-08/15 achieved this weight reduction partly through compromises in cooling capacity that reduced sustained fire endurance, and its mechanism proved somewhat more sensitive to the mud and fouling of trench conditions than the Vickers. The American Browning M1917, introduced in 1917, was in many respects technically comparable to the Vickers. Also water-cooled, also recoil-operated, similarly reliable in sustained fire. The Browning was, if anything, slightly simpler to manufacture and slightly lighter in its standard configuration. But it entered service too late to influence the decisive phases of the Western Front, and its doctrine of employment, developed in something of a hurry by an army new to industrial warfare, never achieved the sophistication of the machine gun corps methods. The French Hotchkiss guns, by contrast, were air-cooled, required barrel changes under sustained fire, and, whilst reliable and effective in their own right, could not match the Vickers for sheer endurance. The legacy of the Vickers extended well beyond 1918. The gun remained in British service, largely unchanged from its 1912 design, through the Second World War, Korea, and into the 1960s. It is a remarkable fact that a weapon designed before the First World War was still considered operationally effective when jet aircraft were standard military equipment. The reason is straightforward. Nothing that came after it improved sufficiently on its core characteristics, reliability, sustained fire endurance, mechanical simplicity, and accuracy in the hands of trained crews, to justify the disruption and expense of replacement. The Royal Small Arms Factory at Enfield conducted periodic assessments of potential replacements throughout the 1950s, and repeatedly concluded that the Vickers remained superior to available alternatives for certain specialized applications. It was only with the introduction of the general-purpose machine gun in the mid-1960s that the Vickers was finally retired from frontline service, having outlasted the tactical era it was designed for by nearly half a century. The influence of the Vickers on subsequent weapons design was pervasive and lasting. Its inverted toggle mechanism was studied by weapons designers across Europe and America throughout the interwar period. The principle of the sustained fire, indirect fire machine gun barrage, codified by the Machine Gun Corps from 1915 onwards, influenced the doctrine of every major army for the subsequent generation. Even the German army, whose own MG-34 and MG-42 of the Second World War embodied a philosophically different approach, faster firing, lighter, intended for both light and heavy roles, had been shaped by the experience of facing the Vickers on the Western Front. The MG-42's extraordinary rate of fire, approximately 1,200 rounds per minute, was a direct response to the need to achieve instantaneous suppressive effect without the sustained fire endurance the Vickers provided. It was a different solution to a problem the Vickers had defined. Surviving examples of the Vickers can be seen today at the Imperial War Museum in London, at the Royal Armouries in Leeds, and at a number of regimental museums across the country. The Machine Gun Corps Memorial at Hyde Park Corner in London, unveiled in 1925, bears an inscription that reads simply, "Saul hath slain his thousands, but David his tens of thousands." The biblical reference was chosen with care. The men of the Machine Gun Corps knew precisely what they had achieved, and the gun that made it possible, the Vickers. With its water jacket steaming in the cold morning air, its toggle action cycling with mechanical indifference to mud, cold, heat, and the passage of time, stands as their monument as much as any bronze or stone. Return then to that chalky pit on the Somme in August 1916. The date is the 24th. The firing has now been continuous for over 100 hours. The men around the gun are exhausted in ways that the gun is not. Their eyes are red, their hands are calloused and burned from handling heated ammunition feeds. They have been living inside the sound of the Vickers, that distinctive, measured cadence, neither hurried nor hesitant, for 4 days. And yet they continue because the gun continues, because the mechanism that Hiram Maxim imagined in his London workshop in the 1880s and that Vickers refined in Crayford through the 1890s and 1900s has proven to be, in practice, almost exactly what its designers intended. A machine that fires and fires and fires again. 1 million rounds. 10 guns, 4 days and nights. Not a single mechanical failure. In an age of industrial war, in a conflict that had demonstrated with terrible thoroughness the capacity of machines to break under the pressures that humans placed upon them, the Vickers machine gun did the one thing that everything else seemed incapable of doing. It kept going, not because it was miraculous, not because it was impervious to physical law, but because it was designed with extraordinary care and precision by people who understood what war demanded of machines, and then built with equal care and precision by workers in Crayford and Erith and Birmingham who never saw the front, but whose skill is inscribed in every round that weapon ever fired. There is a kind of quiet heroism in engineering, not the heroism of the charge or the last stand, but the heroism of the thing that does not fail when everything else does. The Vickers was not glamorous, it was not fast. By the standards of the weapons that followed it, it was heavy, complex, and demanding of its crews. But when the ammunition was loaded and the water jacket was filled and the crew took their positions in the darkness of an August morning in 1916, the Vickers did what no other weapon in the world could do with such absolute mechanical certainty. It fired, and it kept on firing until there was nothing left to fire at, until the war itself was done. That is what it means to never jam.